Namaste everyone, welcome to the class. Today we are going to see probability. Now this topic probability you might have learned in your 10th standard, 11th as well as 12th standard. So basically what the probability is we all know. So let us have a quick revision that what we have done. First, whenever we are studying probability, the first term what we discuss is a sample space. Sample space, it is a set of all possible outcomes. Second, we discuss any event. Event is what? Any event is nothing but it is a subset of sample space. We can say that sample space is the set of all possible outcome and event is the set of all favorable outcome. That means what we wanted to find. And probability of the event. Third is probability of the event is nothing but it is equal to total number of outcome which are favorable to the event divided by total number of outcome in the sample space. So probability of any event is written as m upon n form where m is number of outcomes in event and n is number of outcomes in the sample space. So this is what basically we have learned about probability till 10th standard. Then here we will define axiometric definition of probability. Now this axiometric definition also you have done in your class 12. Axiomatic definition of probability. Axiomatic means axioms. We have used some axioms while defining probability. Axiomatic definition of probability. Now, axiomatic definition of probability, it is defined in 3 points. First is that for any given event A, probability of A is always greater than or equal to 0. This is first axiom, that is probability cannot be a negative number. Second, probability of sample space is going to be equal to 1. And third, probability of A union B will be equal to probability of A plus probability of B provided A and B are mutually exclusive event. So this is axiometric definition of probability, that the probability of A is always greater than or equal to 0, probability of sample space is 1 and probability of A union B is equal to probability of A plus probability of B. Now let us discuss some laws related to probability. First law is we will say laws of probability. First law is probability of B intersection A complement. Now probability of B intersection A complement. For understanding all these laws, it is always better to have Venn diagram. Now I want B intersection A complement. This is B, this is A. B intersection A complement means I want this part. So how you will get this part? You will get this part by probability of B minus probability of A intersection B. And this indicates probability of intersection of B and A. That means all the events of B where A is not happening. And in the same way, we can define probability of A intersection B complement. So in this case, it is probability of A minus probability of A intersection B. So I will say that for any two event A and B, the probability that exactly one of them will occur. So exactly B will occur. So it is probability of B intersection A complement, and exactly A will occur. So it is probability of A intersection B complement. Now, one more theorem we have seen, that probability of A union B. Now probability of A union B means probability of at least one of the event A or B occurs. The above theorem is that exactly one of A or B will occur, and the second is either A or B will occur. So at least one of them will occur. So probability of A union B is probability of A plus probability of B minus probability of A intersection B. Obviously, if A and B are mutually exclusive event, you have probability of A intersection B as 0. So probability of A union B is P of A plus P of B. In the same way, if you have uh, 3 event, so then in that case probability of A union B union C is probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of B intersection C minus probability of C intersection A plus probability of A intersection B intersection C. So this is how we can find probability when 3 events are involved and we have to find at least one of them will occur. So this is probability of A union B union C. Now complementary event. What we understand by complementary event? Complementary event. For any event A, we define A dash as complementary event. So complementary event is A dash. For any given event A, we have A union A complement as sample space and A intersection A complement as null set. Okay, so that means complement of an event is set of all element in sample space where A is not involved. So excluding A, all the elements in sample space, they form complement of an event. Now probability of A and probability of complement of A will give me total probability, or it will give me probability of sample space, which is 1. Probability of sample space is 1. So therefore we define probability of A complement as 1 minus probability of A. So by this definition, we understand that probability of A is always less than or equal to 1. Now De Morgan's law. At many places we have seen this. In set theory also we have done De Morgan's law. Now De Morgan's law, what it says, that probability of A union B complement is equals to probability of A no, I will say that it is probability of A. Here we use union sign, so here we will say that probability of A complement intersection B complement. So probability of A union B the whole complement is probability of A complement intersection B complement, and similarly probability of A intersection B the whole complement is probability of A complement union B complement. This is De Morgan's law. Now in 12th standard, while we begin probability, we have seen conditional probability. Now conditional probability, to revise conditional probability, we will take an example of say we have few childrens in a class in which we have boys and girls. Then we have past students, failed students, and we have total. Obviously, here also we can get total. Now suppose in a class 28 boys passed, 32 boys failed. Total number of boys is 3 plus 2, 5, 60. Total girl passed is 26 and failed is 14. And here we have total 40. Total passed students are 8 plus 6, 4 and 5, 54. Here 4 plus 2, 6 and 46. And here we have total 100 students. Now, if we indicate probability of B as number of boys, probability of getting a boy. Okay, so here probability of B, if you see probability of B, that is, suppose out of 100 you pick one student. Now what is the probability that he is a boy? Your answer will be 60 upon 100. As you can see from this chart that there are total 60 students. So probability of a boy is 60 upon 100. Probability of a boy who passed. So probability of B intersection P. You can see it is 28 upon 100. If I say what is the probability of past students, so total number of students passed is 54, so 54 upon 100. Like that you can find probabilities. Now, what if I say that okay, I pick a student, now that student is pass. Okay, what is the probability that he is a boy? Or I will say that find the probability of a student which I pick is a boy when I know that he is passed. So this is indicated like probability. I want probability of a boy and when I know that he is passed. So probability of B, I will draw a slash line in B. Now what it means, I want to find probability of B. That means I want to check the probability that the student picked is boy when you know that he is passed. So as you know that the boy is passed, that means you have total 54 students out of which you are going to pick one student. So as there are 28 boys, so you can say that 28 upon 54 is your answer. Okay, how you got? You got it from this chart. But if this chart is not there, then how you will get? So for that, you can see this part, and this part is going to help you. Here you are getting 28 upon 100, here you are getting 54 upon 100. So you can say that this is probability of B intersection P upon probability of P. Okay, so this is how we get a formula to get the conditional probability. So here I will say that key probability of A by B. If I want to find probability of A by B, what I will do? I will find probability of A intersection B divided by probability of B. So this second part is always going to come in the denominator. So similarly, if I want to check the probability of B by A, it will be probability of A intersection B. You write B intersection of A or A intersection B, it is one and the same thing. So probability of B provided A is probability of A intersection B upon probability of A. So this is conditional probability, and I will say that this is very, very important. Okay, you must understand how to use this conditional probability. Now using this conditional probability, we can arrive one more very interesting theorem, that is multiplication theorem. So next we have multiplication theorem. Now multiplication theorem, if I rearrange this probability, that is probability of A by B, suppose if I rearrange, what I get probability of A intersection B is equals to probability of B into probability of A by B. Okay, this is your multiplication theorem, and this multiplication theorem you can extend to any number of events. Now this can also be written as probability of A into probability of B by A. So let us understand what it indicates. So probability of A and B, probability of happening of A and B both is probability of B. So I can take any one event first, probability of happening B, then I will multiply it with probability of happening A when I know that B has already happened. Okay, when I know that B has already happened. Now let us understand this with the help of an example. Suppose I have a deck of cards. I have a deck of cards, that is I have 52 cards. Now I draw two cards. Okay, here I want A and B. I draw two cards. Now the question is, what is the probability that the first card drawn is a king and second card drawn is a red card? Okay, so what is the probability that first card drawn is a king and second card drawn is a red card? So probability of drawing a king and a red card. Okay, so that means I wanted to say that, okay, I have drawn two cards. I want one card to be king and the other card to be red card. So probability of king and red. So here I will say that this is probability of red card. So probability of red card is what? Probability of red card is 26 upon 52 into, now I know that I have already drawn the red card. Now what is the probability of getting a king card? I want king as well as red. Probability of drawing a king card and a red card. So once I drawn a red card, the total number of cards available with me is 51, and out of that 51 cards, I am going to draw the king card, which is two cards. I think we will discuss when I will take an example, or here instead of taking this example, we can go at the top and from here we can discuss. Means here I am not getting two cards. Here I want one boy. Okay, I am picking a boy. What is the probability that he is passed and he is a boy? Okay, I pick a student. What is the probability that he is passed and he is a boy? So that I can get from this calculation. This is multiplication theorem. Probability of A intersection B is probability of A into probability of B by A. Okay, so when we use problems, that time we will understand how to use it. So let us start solving problems. Okay, first problem is that there are 11 tickets in a box numbering 1 to 11. 3 tickets are drawn one after the other without replacement. Find the probability that they are drawn in order bearing even, odd, even number. Now I want to get the probability in the order that even, odd and even. That means I wanted to find the probability that first card, I am drawing 3 cards. Okay, the first card will be an even card. Now 1 to 11, how many even cards are there? 2, 4, 6, 8, 10. Okay, so 5 numbers are my favorable outcome. So 5 upon 11 I will take. Now I have drawn a even card. Then I want an odd card. So when I draw an even card, now this is example of multiplication theorem. Probability of suppose A I have done, then I will do probability of B by A into probability of B by A. B by A means A is already happened. That means one even card gone and one card out of total 11 card. So I have now total 10 cards. Now in 10 cards 1, 3, 5, 7, 9 and 11. Total 6 odd cards are there. So out of total 10, probability of drawing an odd card is 6 upon 10. And finally, again when I am drawing, I want to get an even card. So probability of even card will be 4 upon 9 because one even card already I have drawn. So there is only 4 even cards and total number of cards are 9. So it is 4 upon 9. So the problems of multiplication theorem are like this. Okay, we have to find probability of even, odd, even. First card should be even, second should be odd, third should be even. So in this sequence I am going to get the answer. So here you will calculate and get the answer. Calculator is with you. Use the calculator and find the answer. Now this second part, this A part I have done. B part you can do. B is odd, even, odd. So probability of odd, even, odd. So this will be probability of odd into probability of even, provided you know odd. Okay, provided you know odd card already drawn, into probability of, then again you have to draw odd card when you know that probability of even as well as odd you know. Okay, so this how we will get probability of getting an odd card. So total 6 odd cards are there out of 11. Then I am drawing an even card. 5 even cards are there out of 10. Now after drawing these two cards, I have 5 odd cards to draw out of 10, out of 9 cards. So 5 upon here 33 will be your required probability. Simple. Okay. Now let us move to one more problem. In a certain college, 4% of the boys and 1% of the girls are taller than GIR. In a certain college, 4% of the boys and 1% of the girls are taller than 1.8 meter. Further, 60% of the students are girl. If the student selected at random is taller than 1.8 meter, what is the probability that student was a boy? Now, this is a pure problem of conditional probability. Now, here, in two ways we can solve the problem. First, we can make a chart, and from that chart we will understand what is given and we will get the answer. So, if you want to do like that, you will consider let there are total 1000 students. Now I will draw a chart of boys and girls, and then here we have two columns, taller than 1.8 and less than 1.8, and we have total. Now, as per the problem, 60% of the students are girls. So total girls, I know that out of 1000, 600 are girls and 400 are boys. In a certain college, 4% of the boys and 1% of the girls. So 4% of the boys. So boys are 400. 4% of this is 16 and 1% of girl. So out of 600, 1% is 6. 6 girl are taller than 1.8 meter. So rest I can say that smaller than 1.8 meter. So here it will be 384 and here it will be 594. Here if I say total, it is 22. Here the total is 8, 7 and 9, 978. Now required probability. The question is that what is the probability that a student was a boy? Now uh, if the student selected at random is taller than 1.8. Now taller than 1.8, total students are 22. If the student selected is taller than 1.8, what is the probability that he was a boy? So I want to see the probability of a boy when it is known that it is taller than 1.8 meter. So when I know that he is taller than 1.8 meter, we have total sample space as 22 and favorable outcome is 16. So 16 upon 22 will give you answer, that is 8 upon 11. So 8 upon 11 is your required probability. If you want to apply the conditional probability, for that the formula is probability of B intersection taller than. So again it will be very difficult from this given information if you are not doing this chart. Once you do this chart, it is easy for you. Means from this chart you can use the formula also. The formula is, it is probability of B intersection taller than 1.8 divided by probability of taller than 1.8. So B intersection taller than 1.8 is 16 upon total is 1000 divided by taller than 1.8 is 22 divided by 1000, and this 1000 will cancel and you will get the answer. Now let us see the next question. Before I will do this question, let us understand what we mean by partition of sample space. So if I divide sample space in some events which are mutually exclusive, then we will say that it is partition of the sample space. Okay, so here is suppose your sample space and you divide this sample space in some partitions like this. So 1, 2, 3, 4, 5, 6. In 6 partitions you have divided A1, A2, A3 like that you can say. Then probability of A1 union A2, union A3, union A4, union A5 and union A6 will give you answer as 1. So this will be your whole sample space. Now here the question is A, B and C. A, B and C are bidding for a contract. It is believed that A has exactly half the chance than B. B in turns is 4 by 5 as likely as C to get the contract. What is the probability for each to get the contract? Now here, as only 3 contractors have bid, A, B and C, that means it is going to be allotted to any one of them. Okay, and it is also true that when it is allotted to A, then it will not going to be allotted to B or C. So one thing is clear that this ABC is making the partition of sample space. So I can say that probability of A plus probability of B plus probability of C is going to be equal to 1. Now next, if I read, it is given that it is believed that A has exactly half the chance than B. So A has exactly half the chance of B, means probability of A is half of probability of B, plus here we have, and B in turn is 4 by 5, likely as 6C. Okay, so probability of B is 4 by 5. I will say that 4 by 5 times probability of C plus probability of C is equals to 1. Again, this probability of B, I will say that it is 4 upon 5 times probability of C. So everything now is converted in one unknown, which is probability of C. So you can find it easily. Probability of C you take common, then you have 4 upon, so it is 2 upon 5 plus 4 upon 5 plus 1, that is 5 upon 5, you can say, is equals to 1. So therefore 4 plus 2 6, 6 plus 5 11. So P of C is 1 into 5 upon 11, that is 5 upon 11. So probability of C I got as 5 upon 11. Therefore probability of B, which is 4 upon 5 times probability of C, it will become 4 upon 5 into 5 upon 11. It is equals to 4 upon 11. And probability of A, which is probability of A, which is half the probability of B. Half the probability of B. So it is half into 4 upon 11, that is 2 upon 11. Nice question, simple. If event A, B and C form the partition of sample space, again the problem is of partition space. If A, B and C form the partition of sample space and 3 times P of A is equals to 2 times P of B is equals to 6 times P of C, then find P of A union B. So first of all, let us consider that 3 times, I will say let 3 times P of A is equals to 2 times P of B equal to 6 times P of C is equals to, let us consider X. So therefore P of A will become 1 upon 3x, P of B will become 1 upon 2x, and P of C will become 1 upon 6x. Also, as event ABC forms the partition of sample space, we have P of A plus P of B plus P of C is equals to 1. Therefore, P of A, I will say 1 upon 3x plus P of B 1 upon 2x plus P of C, that is 1 upon 6x, is equals to 1. Therefore, here I have x I will take common, and here we have 1 upon 3, 1 upon 2, so LCM we will take. So here it is 2 upon 6 plus 3 upon 6 plus 1 upon 6. As you have calculator, you do not have to take LCM and all those things. Directly you can calculate. 3 plus 2, 5 plus 1, 6 upon 6. Something wrong I am doing, I think. I need to find the value of x. 3 times P of A is equals to x. Okay, no problem. So here what I am getting, 6 upon 6, 1. X is equals to 1. So therefore, P of A is equals to 1 upon 3x, that is 1 upon 3. P of B is 1 upon 2x, that is 1 upon 2. And P of C is 1 upon 6. This is the probability of A, B and C. Right? Simple question. Let us see one more question. Four roads lead away from the jail. A prisoner tries to escape from the jail. Selects a road at random. If the road A is selected, the probability of escaping is 1 by 8. For road B, it is 1 by 6. And for road C, it is 1 by 4. And for road D, it is 9 by 10. What is the probability that prisoner will succeed in escaping from the jail? Now, this is something related with total probability theorem. Now, let me discuss first with the total probability theorem. Suppose here I have sample space and I have some partition of the sample space like this. Okay, so 4 partitions suppose I have, and I have an event. I have an event like this, which is intersecting all these 4 or 5. We have 5. 1, 2, 3, 4, 5. 5 events. It is intersecting all these 5 events. A. So now if I have to find the probability of A, how I will get? So 1, 2, 3, 4 and 5. For that probability of getting A, I will say that it is probability of getting A when it is known that suppose this is event E1, this is E2, this is E3, this is E4 and this central part is E5. So it is probability of A is nothing but probability of A when E1 is known plus probability of A when E2 is known plus like that I have probability of A when E5 is known. This is your conditional probability. Okay, sorry, this is your total probability. Okay, total probability, theorem of total probability means if sample space is divided in some partitions and I have an event defined on all those partitions. Now why I discussed this theorem here? Because if you see the given information, they have mentioned that if road A is selected, the probability of escaping means you know that road A is selected and you want to find the probability of escaping. You know the road B is selected and you have probability of escaping from that road, and similarly for road C and for road D, and you wanted to know what is the probability for escaping from the jail. Okay. The question is what is the probability that the prisoner will succeed in escaping from the jail? That you wanted to know. So here we will define event E1, E2, E3 like that. Here in this problem I will say that let E1 is event of selecting road A. So I will say that E1 is what? Selecting road A. Similarly E2 is selecting road B. E3 is selecting road C and E4 is selecting road D. And I will define event E as success in escaping. So I will define event A as success in escaping from the jail or success in escaping. Now, if you see what is this 1 by 8? if road A is selected, the probability of escaping. So it is probability of escaping when road A is selected. So P of A by E1 is given 1 by 8. Similarly, probability of A by E2 when road 2 is selected, it is 1 by 6. When road 3 is selected, it is 1 by 6. And when road 4 is selected, it is 9 by 10. Now, I want to find probability of A. So, as we discussed in total probability theorem, probability of A will be probability of A by E1 plus probability of A by E2 plus probability of A by E3 plus probability of A by E4. So this will be 1 upon 8 plus 1 upon I am doing something wrong, I think. Yes, the formula which I discussed is something wrong. Here P of A, what I am discussing is not P of A by E1. It is I don't want conditional probability. Actually, I want that E1 is also happening and this A is also happening. This intersection part I want. Okay. So this formula which I have done is I have to modify. Okay. Right. So for that, let us first move this from here. Okay. I have to modify this formula. I want this shaded part. I want. So shaded part, how I will get? I will get this shaded part as it is probability of E1 into probability of A by E1 plus probability of E2 into probability of A by E2 plus probability of E3 into probability of A by E3 plus probability of E4 into probability of A by E4. Okay. Now understand what I have done. What I have done the modification. I want this shaded part. Now this shaded part. Similarly here we have 5 events. So this is plus probability of E5 into probability of A by E5. In multiplication theorem we have already seen that if I want this shaded part, then it is nothing but it is like this probability of E1 into probability of A by E1. Okay. Last time when I have written probability of A by E1, it is nothing but it is to get the probability of A1, E1 is known. Okay. That is different. And if I want that E1 and this A both are happening, that means this shaded part, then I have to use this. Okay, notation. Okay, fine. Now here I will modify this formula. It is probability of E1 into probability of A by E1 plus probability of E2. Now there are four routes. To selecting any of the road is what? It is same. There is no difference, no? Which road he will select. So we will consider that selecting any of the road has got the same possibility. So probability of, otherwise in problem it is mentioned. So plus probability of E3 into probability of A by E3 plus probability of E4 into probability of A by E4. Now probability of E1 is, okay, as I say, it is 1 by 4. So 1 by 4 into probability of A by E1 is 1 by 8 plus 1 by 4 into A by E2 is 1 by 6 plus A by E3 is 1 by 4 into, here it is 1 by 6. Okay, at two places we have 1 by 6, A by E3 as well as, no, it is not 1 by 6, it is 1 by 4. We have this as 1 by 4. So this is 1 by 4 into 1 by 4. And last plus, it is 1 by 4 into 9 by 10. Now use your calculator and calculate. You will get something like 163 divided by 480. Okay, so here in this class, okay, you have to focus majorly on conditional probability theorem, multiplication theorem and total probability theorem. All these theorems you have done in your 12th standard also. So you can revise your that 12th standard book or try to understand from here. Conditional probability, multiplication theorem and total probability theorem. Now we will stop our lecture here. In the next class we will discuss a very important topic called the Bayes theorem, which is obviously based on this total probability theorem, right? So thank you for now. We will see you in the next class.